Hello, chat. Today I'm going to be doing something a little bit different. I'm going to call it like a misinformation hell. I think that's a pretty fitting name. We're going to be going over some various content that's a little dubious, I would say. A little misinformation heavy. But in this video, we're going to be going over a fun little video, part of the series Debunking Evolution, called Adaptation. Now, this is a 12-part series, I think. I just saw a fun YouTuber called Forrest Valkai. Very cool science educator. His channel will be in the description. But he made a video a while back about this video. And I, started watching it. I was like, okay, yeah. And I kind of wanted to make one. You could say I'm inspired. Enough with the introduction. I think it's time to start the video.
Is it just me, or has the evolution from one kind of animal into another never been seen? So Darwin's finches left South America, traveled to the Galapagos Islands, and over time, each island developed its own species. But is that really evolution?
Yes, that is what evolution is in fact, but well, not yes to you questioning its existence, because it does exist, and it is a thing.
Jane, look at it. Got a new app for my phone. Flashlight. I love this phone. It's got everything you need on it. It's got GPS, it's got constellations. What did people do before smartphones?
Their homework?
Dude. We're already off to kind of a bad start here. John appears to be fascinated by a flashlight on his phone. I do not think this boat wills for the rest of this video. I agree, it's marvelous technology, but it's not something to be like, oh my god, this is so cool, I have a light on my phone.
Your smartphone is pretty amazing, but it can only do things it's programmed to do. Hey, that's it! That's the difference!
What's the difference?
I've been reading through a textbook, and they keep giving great examples of how creatures change, like Darwin's finches, or these tortoises. But this isn't evolution by natural forces if these animals were programmed to adapt like that.
That is a very interesting proposition, but what do you mean exactly by programming? I'm interested. I'm intrigued, you could say.
I see what you're saying. Many evolutionists consider any change as evolution, which makes it seem like we're always evolving upward.
Okay, I'm gonna have to stop you there for just 1 second. Nobody who can call themselves an evolutionist would say that things evolve upwards. In fact, the only people who are proposing this idea are uneducated folk like yourself, attempting to propose a straw man. I'm pretty sure one of the main reasons people get caught up on this idea of evolution being a ladder, ultimately reaching some sort of end goal, is because of this illustration, this dumb thing that still gets people caught up. I honestly, if this was never a thing, we would be so much farther along in society. This image is called The March of Progress by Rudolf Zollinger. But it was originally created to give an early understanding of evolution to the general layman population that had no idea about the concept of the time. It was just created to give a very broad, very just evolution makes you change, just an extremely basic thing like that. It was never made to give the full understanding of evolution. It was never supposed to be taken absolutely literally. Stephen Gould put it the best. I just seen this quote today. The March of Progress is the canonical representation of evolution, the one picture immediately grasped and viscerally understood by all. The straitjacket of linear advance goes beyond iconography to the definition of evolution. The word itself becomes a synonym for progress, but life is a copiously branching bush, continuously pruned by the grim reaper of extinction, not a ladder of predictable progress. Also, I said continuously, not continually, but that shouldn't change the whole gist.
But not all changes come from accidental errors through mutation. Some pre-programmed variation helps animals adapt through genetic recombining.
Now, what I think they're trying to get at here is a form of evolution called genetic drift. Genetic drift essentially states that there are small, differentials between every organism in a given population that kind of get shuffled around as all the organisms reproduce, which this in turn causes harmful, less important, deleterious traits to fade, to go away, because the creatures that are most likely to be reproducing are ones that are surviving, and of course deleterious traits cause them to be less likely to survive and then reproduce. And then this of course applies oppositely to helpful traits, because organisms that have more beneficial traits are going to be more likely to survive, and they're of course more likely going to be able to reproduce and pass on those specific helpful traits.
Look at this. Our book lists the sources of genetic variation. This page lists the two main sources of change as mutation and genetic recombination.
So mutations would be accidents, errors?
Right. Mutations are usually caused when there's an error copying a creature's genetic information, which is found in its DNA. It can lose, duplicate, or even copy letters in the genetic code.
But if I delete, scramble, or duplicate letters, won't I eventually get a new word?
Sure, but a new word doesn't necessarily mean anything.
So if I scramble the letters in puppy, it just means gibberish?
Exactly. Mutations might be able to create a new combination of letters, but it needs to have a meaning for the cell to use as a blueprint later on. In other words, a code isn't really a code without some assigned meaning. Gibberish can't create anything.
Okay, well, holy I guess I'm gonna have to explain how DNA works and how it's coded. Stay tuned, because this is going to be an explanation. There are 4 types of codons, or I already ruined it. I'm out of it today, I guess. There are 4 types of nucleotides that code for codons: adenine, cytosine, guanine, thymine. But because of transcription, thymine becomes uracil. So we're not talking about thymine here. So just wipe thymine from your mind. It's uracil. This right here. This is a codon chart. You're going to be in love with this codon chart for just a bit, because it's very, very important for this. Any 3 combination of nucleotides make a codon. These codons then make up proteins that make up your DNA, essentially. Each codon codes for something, whether that be a start codon that starts the protein chain, or a stop codon that ends a chain, or literally anything in between that. Alongside that, there are a lot of mutations that can possibly occur. There are a lot of possible mutations that can occur. Now, one of which is a silent mutation, which is when a nucleotide, let's say this one right here, gets changed to a different nucleotide, to a different letter, but that the changing of the letters does not affect the final thing it's coding for. So it's silent. It doesn't do anything. It doesn't actually affect the protein function. But then you have like the actual like harmful ones, which are missense and nonsense. Missense is when a codon, in a codon, a nucleotide is changed, and that results in the actual change of the function. So it causes the codon to code for something else. Now, that can just completely change the function of the protein. That'll completely change the function of the DNA, and then that it could either be good or bad. The final mutation we're going to talk about is the nonsense mutation, which is when a nucleotide in a codon gets changed, causing it to code as a stop codon. Which, when that happens, the entire chain of codons just stops right there. All production stops. That's the chain. It stops there. Now, going even further than this, you can have duplication event, you can have deletion event, you can have a translocation event. Each of those do different things. But in a duplication event, you have a codon being basically duplicated, and you have two codons that are the same in a row when there shouldn't be. Deletion event, which is when a nucleotide in a codon gets deleted, causing like all the codons and nucleotides in front of it to be like shifted back one, which will just change every single one of them because you're pushing it back. So you have like you may have like uracil, guanine, cytosine, and then like cytosine, guanine, uracil. That cytosine on the beginning of the second codon will be shifted back because one of the nucleotides in the first one got deleted, so it just gets pushed back. And then every single codon after that will now be one different, which will completely change all of their functions. Or maybe some of them will stay the same because it'll be a silent mutation. It really just depends. And now, like, getting the full picture of how all of these mutations, codons, nucleotides work, you can see how complicated all of this is, and how the creation of a single protein is so complex. It's not comparable. It's not comparable to an English word being changed around a little bit, and then you get a new word. That is such a false comparison.
So mutations are always bad?
Yeah. Look at what it says. Some mutations, such as those that cause genetic diseases, may be lethal. Other mutations may lower fitness by decreasing an individual's ability to survive and reproduce. Still, other mutations may improve an individual's ability to survive and reproduce.
The crazy thing is there, John, is you tried to make the claim that all mutations are bad or negative or deleterious. And then you immediately, in the next sentence, read a line saying, still other mutations may improve an individual's ability to survive and reproduce. How do you do that? That is like a superpower. Like, you went straight. You ignorantly just said something, and then immediately read off why that's wrong right after saying it. And not even just that, you also like failed to hide or failed to read what the next paragraph says. Maybe don't put the thing that debunks your argument in plain view next time. I'm not kidding you. It literally says in the next paragraph, how common are mutations? Recent estimates suggest that each of us is born with roughly 300 mutations that make parts of our DNA different from that of our parents. Most of those mutations are neutral. One or two are potentially harmful. A few may be beneficial. How did you do that to yourself? you just like said something and then had all of the things you needed in plain view to debunk it. How do these people exist?
It looks like they agree that mutations are bad, but then why do they say some may improve an individual?
They give you an example right here. Over the past 20 years, mutations in the mosquito genome have made many African mosquitoes resistant to the chemical pesticides once used to control them.
Okay, so it looks like the mosquitoes are better off because of mutation.
Yes, but what they don't tell you is that resistance actually came from a loss of information in the mosquito's genetic code. The mosquito's ability to control its enzyme production is now messed up, and one of the strange side effects of too many enzymes is increased pesticide resistance.
Okay, slow down there for just a second. You cannot you cannot say the word enzymes in that context, in that way. You cannot use enzymes as a blanket term that you could just have too much or too little of, because enzymes are like very, very specific things that are very, very specifically made to do very, very specific functions. You can't just say like having too many enzymes without giving more context to that.
However, normal mosquitoes without the disease are much healthier in the wild where there is no pesticide.
So it was a loss of information, but it was a benefit for those mosquitoes, right?
Well, they only benefit by being more resistant to the pesticide.
Yes, that was the point of the mutation.
The point is, by losing information, they lost control of an enzyme's production. Now, evolution needs to explain gains of information over time. And the same goes for other examples they give, like bacteria becoming more resistant, bone density, humans becoming more resistant to HIV.
But if a population of creatures continues to lose information, could it be deadly for them?
Bingo! But here's the real problem. People count on that loss of information from mutations to create the genetic blueprint for every living creature on Earth out of nothing. That's crazy.
No way, that's so impossible. It destroys evolution.
No. It doesn't work like that. And we don't do that. We don't say that. Even playing devil's advocate and saying that it does work like that, it still shows that evolution occurs. It still demonstrates a clear benefit for these organisms. It's really stupid saying that evolution only occurs from a loss of information, because that implies that at a certain point we won't have any left, and this video gives nothing to like explain how we originally got all that information that we're just like throwing away through adaptation. Did we start as having like an incredible amount of information, and then over time now we've reached this point and we have way less because we've adapted and we've just lost it all? Because that's like one of the stupidest things I've genuinely heard this week. That's insane.
Right?
Okay, so what about the other changes? Program change, or you called it genetic recombination.
I think you meant to say genetic drift there.
Look at what it says here. Most heritable differences are due not to mutations, but to genetic recombination. So God not only created all the animals, he also packed them with enough genetic information that would allow them to adapt to different environments and varieties we see today.
So adaptation is real?
Yeah, I saw an explanation of it in the Focus on Earth Science. Individuals with characteristics that are poorly suited to the environment are less likely to survive and reproduce.
Over time, poorly suited characteristics may disappear from the species.
This may come to a shock to you, but that thing you're describing there is a fun concept. No, not even concept, a fun theory called evolution, or more specifically, like natural selection, but evolution.
And while we've seen some pretty amazing varieties within the kinds God created, like in dogs, one basic kind of animal can never change into another.
And that fits with all the examples we see in these textbooks.
Although they like to point out the differences in finch beaks and tortoises.
It's just adaptation within the genetic limits of that kind.
And they've harped back on the idea that only changes in kinds can occur. Please, all creationists out there, please don't make this shit argument.
Kind of makes you think, doesn't it?
If anything, Jane, I've lost a few thousand brain cells. Wow, this video was absolutely, truly atrocious. I hope I pick a harder video next time, because that was kind of sad. I feel bad for the people that watched this video and was like, yeah, they're making good points. Yeah. Anyway, I hope you have a great rest of your day, or night, or afternoon, or morning, whatever time of the day it is. I hope you have a great of that.
Not a single moment. All I want is to take off.